Welcome to iTTV for Form 2 Science, where we continue with the world through our senses. Today's lesson, the sense of taste. We all like food. I think we all understand that we all also not only like food, but have a particular taste that we really enjoy. Me personally, my favorite thing is probably coffee. Coffee has what we call a bitter taste. All the other people here in the studio with me have their own special tastes that they like. The cameraman loves salty. The director likes sweet. The producer likes sour. These are our main tastes. What we're going to do today is investigate where these tastes are in our mouth, or on especially our tongue, which is our main sense organ that we're going to look at, and how our tongue allows us to detect these tastes. We taste with our mouth. The tongue is a taste organ. The tongue is sensitive to taste. The stimulus are chemicals, taste, in food or drinks. What we are saying here is that the stimulus are chemicals, similar to our nose. With our nose, the chemicals are floating in the air. In the case of the tongue, the chemicals are actually inside the food itself. As we chew the food or we take the food into our mouth, these chemicals will be released, and when these chemicals hit the receptor cells, the stimulus is detected. It is sensitive to sweet, salty, sour, and bitter tastes. Now, this is what our tongue can detect. I know you're thinking that, if I eat chicken, it doesn't really taste sweet, sour, salty, or bitter. Some foods, the taste is basically a creation of the combination of different tastes. Let me sort of explain this to you here on the board. The first thing we want to do is have a look at the structure of the tongue as we sort of know it. And what we want to do is identify the main taste areas. We have one at our tip of our tongue here. This is our sweet area. And then along the side of our tongue, we have two other areas. I'll shade this one in here, and we'll put another one in over here, like so. These two are, first, your salty, followed by, over here, sour. Finally, the last of our tastes sits at the back of our tongue, over here, and this is the bitter area. So what we're saying is that when you eat, these are the areas of your tongue that actually detect the stimulus of taste. Believe it or not, if you actually put some food just right in the middle here of your tongue, there would be no taste. Because in the middle of the tongue, we have no taste receptors. The receptors are on the outside area of the tongue, the tip, and at the back of the tongue. There is also receptors on this side. They are the salty ones over here, and the sour ones also over on this side. So those are the main areas where we detect taste. Now, when you taste something that isn't sweet or sour or salty or bitter, it has its own unique taste. Like example, the taste of cashew nuts, or the taste of almonds, or the taste of fish, or the taste of chicken. These tastes are a combination of tastes. Now, the best way I can describe it is with colors. If you take the color blue and you add to the color blue some, say, color red, like this, well, When you take blue and red and add them together, you sort of get purple, or sometimes we say magenta. So what I'm trying to say to you is, it works very similarly with our tongue. When you eat something, example, that is a bit sweet and has a bit of salty in it, when you combine these two together, you get a unique taste, which might be the taste of almonds. You eat something else, which might be a bit of bitter, plus a bit of sour, maybe a little bit of sweet inside as well, then you might get a totally different type of taste, which might be, say, the taste of soya sauce. So different tastes are a combination of the four main tastes that we have on our tongue, which are the sweet, salty, sour, and bitter. How are these tastes detected? Well, as we've been through in the other lessons on the sense organs, every stimulus is detected by receptors. So let's find out where the receptors are and where they are kept and how they work. The tongue is covered with many taste buds. The taste buds contain the taste receptors. So our tongue has got taste buds. So you're going to find the taste buds sitting in these areas here. These taste buds, which are specialized cells, they contain the receptors inside them. Each type of taste bud is sensitive to one type of taste. So what we're saying here is that we obviously have four different taste buds. We have a taste bud that is unique for sweet. We have a taste bud that is unique for salt. Sour has its own taste bud, and bitter has also got its own taste bud. Each taste bud has a slightly different shape and size, and a method by which it detects those chemicals that are the stimulus. Now that we've been through the first part of the tongue, which is the tastes and the taste buds, let's try a quick question before we move on. The taste bud is sensitive to one type of taste. How many types of taste buds do we have in the mouth? What you should be thinking here is, how many tastes do I have? Each taste has got to have its own unique taste bud that detects it. So that will be able to give you an idea what your answer should be. Have you thought about it? Let's check and see if you're right. The answer, 4 types, because we can detect 4 types of taste: sweet, sour, salty, and bitter. So remember, if we have 4 tastes, we need 4 taste buds. If, for instance, we had more than 4 tastes, which is, say, we had 7 or 8 different tastes in our mouth, then we would have to have 7 or 8 different types of taste buds, each one detecting a particular type of stimulus. Let's move on now with the lesson. What we want to do is have a look at this unique combination between the mouth and the nose. The sense of taste and smell work together. This is why you can't taste food when you have a cold. Basically, the mouth and the nose are connected by the nasal passageway. They need to work together. Some of the chemicals from the food will actually move up to the nose and stimulate the olfactory cells in the nose. Together, they both fire messages to the brain. The brain then helps detect the taste and the smell together. If one of the two are not working, then basically both the sense of smell and taste is going to be slightly inaccurate. So it's very important that both the nose and mouth are working at the same time when we want to taste, or for that matter, want to smell. And when we have a cold, because the sense of smell is not really working very well, because there's too much mucus in the nose, the sense of taste is also affected. You might have noticed this when you've had a cold. You've had a cold and your mom gives you some chicken soup or chicken broth to eat, and you can't actually taste anything. It's pretty hard to eat it when you can't taste it, but your mom says it's good for you, so you do. But the point that I want to make is you can't taste it. So this is an example of when one of the organs, the nose, is not working, the other sense organ, the tongue, is also affected by it. Detection of taste by the taste receptors. What we want to do now is have a closer look at how those taste buds and the receptors actually work on the tongue when we are eating. Food and drinks in our mouth dissolves in saliva. Very similar in what happens in the nose. If you recall, in the nose, the chemicals that come in actually dissolve into the mucus. While in the mouth, instead of having a mucal layer, we have saliva. Let's have a look at what happens with a diagram. Now, we already know that we have a tongue that has got the 4 detectors on it. So, when you eat, imagine that the food comes into this middle area here. We have our food. This food now is going to dissolve in the saliva. When the food dissolves in the saliva, all the chemicals now are sort of in a liquid layer. These chemicals, which will represent by these dots inside here, are able to move around the mouth with the saliva, because the saliva is a liquid. As the saliva moves around inside the mouth, these chemicals end up moving to all parts of the tongue. Now, as these chemicals reach the bitter, sour, salty and sweet areas, these chemicals move into the receptor cells and start to do their stimulating. If, for instance, there is sweet inside this food, then the sweet area will start to fire signals to the brain. If, for instance, there is some salty inside the food, well then the receptors in this area will start to fire to the brain as well. If there's no sour inside that food that you've just eaten, then there is no signal being sent to the brain. If there is some bitter inside the food that you've eaten, well then the bitter receptors fire off a message to the brain. And basically, this is how the tongue is going to be able to work. So it's very important that the first step occurs. The food must dissolve in the saliva. Chemicals from the food or drinks stimulate taste receptors in the taste buds, which is exactly what we've just demonstrated here on the board. Once the chemicals have dissolved in the saliva carries these chemicals to the areas around the tongue where our taste buds are situated. If a particular chemical is present that stimulates that taste bud, then that taste bud will fire messages to the brain. The taste receptors send the information to the brain. This information is sent along the nerves. We don't have a particular type of nerve for our tongue, not like we have for the ear or for the eyes. For the tongue, we just have a whole bunch of nerve cells that come down at the bottom of our tongue and move straight up to the brain. You could almost say that each receptor itself was connected to the brain directly. This means that if there are more chemicals, you will get a sensation that it is more sweet or saltier. If there are less chemicals, less taste buds are stimulated, so the sense of the taste is diluted. It is not so strong. So you could say it is not very bitter or it's not very sour. So it all depends on how much of those chemicals are present in the food source. This is something that we use quite a lot in the food industry. If you want to make something that is very strong, you tend to put more of the chemical inside. If you want to make something that is not so strong, that is not very sweet or not very salty, then the idea is you put less of the chemical inside. By manipulating the amount of chemicals, we can manipulate the taste that someone has inside or on their tongue. The brain identifies the type of taste that is detected. And this finally is quite important because your brain is going to decide whether or not it likes that taste. Like I said earlier, I like bitter tastes. I also like sweet tastes, but I certainly do not like salty tastes. I can't remember when in my life it started, but at some point my brain was sent a message about salty and it just didn't like it. So every time I eat something that is salty, my brain, which identifies this taste as salty, actually makes me feel a bit sick or nauseous. Which means to say that salty doesn't agree with me. My brain doesn't like it. Now, we all have this. We all have particular tastes that we don't like. And if we don't like a particular taste, then, well, that is because of the messages that have been sent to our brain in the past. All right, now that we've gone through the whole process of the tasting and how our tongue works, let's just do one or two quick questions on what we've learned so far. How do we detect a taste? Remember, those chemicals have to be brought to the receptors in the taste bud. There must be a mechanism or a method by which the chemicals are transported. Can you remember how it happened? A hint I can give you is in the nose, the chemicals had to dissolve in the mucus. A very similar process occurs on the tongue. Now you've thought about it for a while. Let's see if your answer is the same as mine. The chemicals in food dissolves in saliva and stimulates the receptors in the taste bud. So remember the two key moments here. Number one, the chemicals must dissolve, and they dissolve in the saliva. The second key moment is the saliva brings the chemicals to the receptor cells and they are stimulated. Number one, dissolve the chemicals. Number two, stimulate the receptor cells. Let's try another question. Why does ice cream taste so good? Now this one is a bit of a thinking thing. What I need you to do is think about how you would eat, example, an ice cream cone. What do you do? So now that you're thinking about how you eat the ice cream cone, think about where the ice cream, what part of the tongue the ice cream is actually touching. Try and put the two together. Okay? Now that you have an answer, let's see if your answer is similar to mine. Because we lick it with the tip of our tongue, the tip is sensitive to sweet taste. So, remember what we've learned about today's sense organ, the tongue. It has four main tastes that it can detect. Sweet in the front of the tongue, salty, sour along the side of the tongue, and bitter at the back of the tongue. Each of these tastes are produced by chemicals. The chemicals stimulate the taste bud receptors in the 4 areas of our tongue. When these taste bud receptors are stimulated, they send messages to the brain, and the brain interprets this as a particular type of taste. Remember, in order for us to be able to taste something, the food must first dissolve into our saliva. That's all the time we have for today's lesson. Thank you for watching ITTV.